of his students are going to take over his show. Unfortunately, as you can see, they're probably not his best students, but they're going to get there, so don't worry about it. But instead of the painting, we're actually going to talk about organic chemistry of paint. So paint has three main components. It has pigments, it has the binder, and it has the solvent. So as you can see, the pigment gives the three paints different colors. So this has a yellow pigment, a red pigment, and a blue pigment. So they're very helpful to differentiate different paints and modify to the color that you really want. So popular examples of organic pigments are azodyes, phthalocyanine, and anthraquinone. Next, we're going to talk about binders. Binders really make this whole thing come together, helps the particles stick to the paper and to each other. And you can see how now the paint is really running, they're just kind of sticking there. So typical binders include acrylic polymers, alkyl polymers, and epoxy polymers. Lastly, we're going to talk about solvents. So solvents is the medium in which the binders and the pigments all come to one.
Alright, so Archie wanted to take his lunch break, so I'll be filling in for you now. So I'm going to run you through the basics of the pigments and how they are formed in like an organic mechanism and what the organic structures look like. So on this next page, we've got a diazonium compound and a aromatic compound. So this is the diazonium compound, as you can see by the nitrogen triple bonded to each other with a cation there. And then this is just a phenol ring that we'll be using in this reaction. This reaction is called azocoupling, and it forms an azo dye, which is a typical pigment that you can see in many paints. So I'm going to run you through the arrow pushing here with my lovely red paint. So what you see here is an attraction of that molecule there, or those electrons go to that cation. Then we have, that goes there, and we see just the delocalization of the all right, so this is the first step of the mechanism, and what we're going to see is a change from the triple bond to a double bond, and then a change in the structure of the double bonds in the aromatic ring, and then a positive charge on the alcohol group here. So the next part of the mechanism that we're going to see is this has to occur in a basic solution. So the base will attract this proton, and then we'll have this come back here, this there. All right, and then that will finish up our mechanism, and we'll end up with this. See, this azo dye is actually solvent yellow 7, as you can see here. If you're having trouble imagining the color yellow, I'm going to draw for you a picture of the sun. Let's see. All right, there we go. We've got a nice sun to go with our nice little organic chemistry. Now I'm going to run you through the structures of the phthalocyanine and the anthraquinone. So I'm going to do anthraquinone first because it's easier to explain. So we've got 3 6-membered rings connected to each other. Now, most dyes will be formed when there are substituents on either of the aromatic rings that aren't in the middle. So what you might see is, like, for example, if you have an OH here and a NH2 there, then you can go into like an O and then pH. If you imagine that is another benzene ring, then you'll have a dye that is a red dye, similar to what we're using here. All right, now I'm gonna go through the structure of phthalocyanine. We're gonna use blue for this one. So phthalocyanine is formed by essentially the combination of four molecules called isoindoles. So an isoindole four isoindoles, which is this compound here, makes a phthalocyanine, which I've drawn on the next page. As you can see, there's one isoindole here, one here, one here, and that makes four. And then, as you can see, the nitrogens here are what is connecting those isoindoles. Typically, the isoindoles will be stabilized by a copper or another sort of metal in the middle here. And then again, the derivatives off of the aromatic benzene rings are what will form the basis of the dye. All right, now that I've talked to you about pigments and what and how they're formed and what they're made of, we're going to talk about binders and how the paint is held together.
Hi everybody. Christian went to go search for Archie, so I'm out here to teach you all about binders today. Now, binders, as we know from before, are the reason that the pigments in the paint stick together. When you put them on a wall after it dries, the reason all the paint doesn't just chip off or come down off the wall is because of binders. There's certain polymers that keep everything together. You could have, for example, an acrylic polymer, or an alkyd polymer, or an epoxy polymer. So, I want to give you a little example on how you make an alkyd polymer. So we're going to grab our paint here. I like blue, and we're going to have two different reactants. I've so nicely drawn out is dicarbonyl, which would be our starting point for this polymer. Next, we're going to have to react it with another molecule. We have our alcohol. Now, when our alcohol and our dicarbonyl react, we're going to get a nice little polymer we call an alkyd. Now, our alkyd here, since it is a polymer, of course, we're going to need to add some brackets around it. Now, as we all know, a polymer is a repeating chain of organic compounds. This specific polymer is an alkyd, and it will repeat around our brackets here. When the alkyd polymer, as I previously stated, is put in the paint, it's going to keep all of the pigments we previously mentioned together and allows us to have our happy little accidents that we get to paint out. So now we're going to talk about solvents.
I had to go somewhere, so let's get crazy and talk quickly about solvents. So solvents are the medium where the binder and pigments are dispersed. So once the paint is applied to the surface, the solvent begins to dissolve, and that's why the paint dries. So we're going to draw a flower to go with our chemistry and our sun, and just to show you how that works. So as you can see, the paint's beginning to dry, and it's not coming off on my fingers, and that just shows the solvent evaporating. And so some common organic solvents for our organic pigments that we were talking about are xylene, toluene, and different kinds of alcohols like isopropanol or also N-butanol, and then also various kinds of ketones. And knowing about solvents is important because they change the viscosity of our paint, and so I'll tell you what, I'm gonna go find everyone else, but I hope you enjoyed this